A year ago, building an AI agent meant installing one massive universal framework. Now, that ecosystem is splintering into highly specialized micro-frameworks. If you are building a system today, you have to choose between fully managed cloud services, heavy Node.js environments, or hyper-optimized Rust binaries. This chart maps the major players right now: OpenClaw, MaxClaw, ZeroClaw, Space Agents, and IronClaw. The trade-off comes down to two variables: deployment speed on the x-axis and how much data control you need on the y-axis. Pick the wrong one for your specific project, and you could end up leaking enterprise credentials, burning your budget on unnecessary compute, or wasting days fighting Docker containers just to send a basic automated message. The decision is no longer about which agent is the smartest. It is about choosing between the scale of a community ecosystem and the exact execution architecture your hardware demands. Let's start with the platforms optimized for zero-friction deployment. These fully managed cloud solutions require zero infrastructure management. You type a text prompt, hit enter, and you have an agent capable of complex reasoning live in under 10 seconds. This image shows Hugging Face Spaces. It gives non-technical users a browser-based environment to spin up workflows instantly, without installing a single file. Here is the Minimax launch screen, the engine behind MaxClaw. It relies on the M2.5 model to deploy agents straight from a mobile-friendly interface. That speed comes with a steep tax. You sacrifice all data sovereignty, accept complete vendor lock-in, and lose all local file access. If you need local control, the default answer is OpenClaw, a massive 400,000-line Node.js framework. Its sheer size is what gives you access to a huge plug-and-play ecosystem featuring over 5,700 community-built skills and deep multi-channel messaging integrations. That scale allows developers to build deep meta frameworks on top of it, like the OpenSpace self-evolution engine. This flowchart breaks down how OpenSpace actually works. When an agent fails a task, the engine autonomously diagnoses the error, rewrites its own code to fix the broken skill, and executes again. Over time, remembering these exact fixes cuts token usage by 46%. But running that ecosystem takes a heavy toll. It demands a 1.5 gigabyte RAM footprint, requires long startup times, and exposes operators to severe supply chain security vulnerabilities from importing unvetted community code. To solve that bloat, developers built the exact opposite architecture: hyper-specialized micro-agents like ZeroClaw and PicoClaw. They stripped out the massive node dependency trees, replacing them with compiled, trait-driven micro-binaries written entirely in Rust and Go. This side-by-side comparison shows the difference. OpenClaw demands 1.5 gigabytes of memory, while ZeroClaw operates in less than 10 megabytes. That efficiency lets you deploy persistent AI agents on $10 Internet of Things hardware, tightly constrained virtual private servers, or even a Raspberry Pi. Adopting these micro-agents means you have to abandon the massive community skill marketplace. You will have to build and configure your own tool integrations manually. Finally, we have to look at environments where a data leak or prompt injection carries severe enterprise-level consequences. For these high-risk deployments, frameworks like IronClaw and NanoClaw prioritize hard, system-level security boundaries over ease of use. This diagram shows IronClaw's 5-layer defense in depth, keeping the agent locked inside a WebAssembly sandbox. NanoClaw goes a step further, using OS-level virtual machine isolation, so the agent physically cannot touch the host system. Here's the Anthropic logo, which represents the base model's internal safety alignment. Hard-coded sandboxes exist because relying entirely on an AI's philosophical constitution to prevent a malicious action simply isn't a secure enough architecture. Achieving true zero-trust security creates immense operational friction. Every time you add a new capability, you have to manually navigate strict endpoint allow listing and capability permissions. AI governance exists on a spectrum. The right choice depends entirely on balancing convenience against compute overhead and security risks. We can map this out on a decision tree based on your primary constraint. If you are a non-technical operator who wants to generate content or basic automation without touching a terminal, follow the top branch to Space Agents or MaxClaw. If you are building complex, multi-API workflows that require a massive plugin library and self-learning tools, take the middle path to OpenClaw and OpenSpace. If you are a systems architect operating on constrained edge hardware or handling sensitive data that requires strict memory safety, the bottom branch leads you to ZeroClaw or IronClaw. There is no single best AI agent in 2026. There is only the framework whose execution architecture perfectly matches your operational reality.